Good evening, and thank you all so much for joining us for tonight's David Elder Lecture, which are hosted in partnership with the University of Strathclyde. I'm delighted you could join us, and I do hope you enjoy the lecture. My name is Nina, and I'm the Planetarium Coordinator here at Glasgow Science Centre, and I'll be looking after the live Q&A portion after the lecture. Shortly, I'll be introducing our guest speaker. After watching his lecture, I'm certain you're going to have quite a few questions for him. So to ask those questions, we ask that you pop them into the YouTube comments box or the Facebook chat, and my fantastic producer, Yvonne, will get them to me. Without further ado, I'd like to introduce tonight's speaker, Professor Mike Brown, who's joining us from Caltech. It's about 11 o'clock in the morning over there, so a wee bit earlier in the day. As a bit of background information for Mike, he scans the skies searching for and intensely studying distant bodies in our solar system, and that's all in the hope of gaining insight into how our planet and the planets around it came to be. In this quest, he's discovered dozens of dwarf planets and demoted, or might say reclassified, one object from a planet to dwarf planet, and is currently hot on the trail of Planet 9, about which we'll be hearing a bit more tonight. This is a hypothesized body that's possibly the fifth largest planet in our solar system. He is the Richard and Barbara Rosenberg Professor of Planetary Astronomy at the California Institute of Technology and has been on the faculty there since 1996. Feature articles about Brown and his work have appeared in the New Yorker, the New York Times, Los Angeles Times, and Discover, and his discoveries have been covered on front pages of countless of newspapers worldwide, including here in the UK. And at Caltech, he teaches undergraduate and graduate students, and that's in classes ranging from introductory geology to formation and evolution of the solar system. Some of these lectures are actually available online to the public, and I would very much recommend that you have a wee look at them. I'll pop some links into the Planetarium Twitter after the lecture. And he was especially pleased to be awarded the Richard P. Feynman Award for Outstanding Teaching at Caltech. So without further ado, I'd like to welcome Mike to the page, to YouTube. Hi, Mike. Thank you for joining us.
Thank you for inviting me. It's my pleasure to be here, and I'm happy to have a chance to talk about Planet 9 this morning for me, evening for you guys.
Fantastic. Well, I'm going to, without further ado, hand over to you because I think people are here to hear from you rather than from me. So yeah, thank you again for taking part in this lecture series, and I'm looking forward to this myself.
Great. Thank you. So I'm going to talk about this planet that Nina mentioned that we're on the trail of Planet 9, we call it. But to talk about this ninth planet, we really have to go back in history and talk about the discoveries of the other planets and a little bit about the demotions of some things that we used to call planets that are not planets anymore. So let me take you back. I want to take you all the way back to something like 1780. If the year is 1780 and you look up in the sky, you can see all of the known planets. You can see Jupiter and Saturn really bright. You can see Mars sometimes in the year at different places. Venus also really bright. You can see that in the sky these days. And Mercury, even if most people haven't seen Mercury, but you could see it if you look carefully. And that was it. 1780. Those are all the planets in the solar system. There really was, as far as I can tell back then, no speculation that there were more planets to be found. It was not something that people thought was out there. They thought Saturn was it. There's nothing else there. And so it was a surprise when William Herschel built his fancy new telescope and started scanning the skies and mapping out the positions of stars. He was surprised when he found something. It was kind of fuzzy looking the first night he saw it. And so he went back to look at it the second night. And the second night he looked at it, it had moved. Moving is the characteristic of things in our solar system. All the stars, all the galaxies, all the nebulae, they're in the same place with respect to one another night after night after night. But everything in the solar system moved. So when Herschel saw this body move, he realized it was something in the solar system. But even he didn't immediately jump to the idea that he had discovered a new planet out there. It just didn't seem likely to him that that's what it was. So it took many years before people were convinced that this thing was actually a planet. This is, of course, the planet that we now know know as Uranus. But until people could really convince themselves that it went in a circle all the way around the sun, stayed outside of Saturn the whole time, nobody really quite knew. The first person who actually made a convincing case that this was a planet, that this was outside of Saturn, was a French astronomer, Alexis Bouvard. And Bouvard cataloged the position of Uranus at all the points from its discovery onward and started calculating where it should be based on physics, based on the way that Jupiter and Saturn gravitationally tug at it. And he also did something really interesting. So if you look at this table of his, you can actually see the discovery of Uranus here, 1781, and you see all the dates coming up. Actually, I don't know the answer to this. Do you see my cursor if I point with my cursor on this one? If anybody answers yes. Okay, good. You see my cursor. 1781, you see the dates that are here. All these dates after 1781, they're observations of Uranus, but they're actually all these before 1781 too. Uranus was first actually seen in 1690. In 1690, it was seen and not recognized as a planet. And the reason it wasn't recognized is because an astronomer looked at it. It looked like a star. And he didn't go back and look at it the next day and didn't notice that it had moved. Same thing happened in 1712, 1715, 1750. All of these astronomers had cataloged Uranus as a star in a place where there are no stars today. Bouvard realized this, and he went all the way back to 1690 for his positions of Uranus. And he did some math, did some physics. You can see over here. You can check his answer, see if he got it right. But what he realized is that the predictions of the location of Uranus, his predictions, were off. This is where you can see the errors here: slightly ahead, slightly behind, slightly ahead, behind, ahead, behind, ahead. And what he decided, so Bouvard was really the preeminent theoretical astrophysicist of his day. And I know people today who are similar. They are the theoretical preeminent theoretical astrophysicists of day, and they would have the same response. What Bouvard said is that it must be his theory is perfect, his calculations are perfect, so it must be that the observations are wrong. He said to astronomers at the time, make better observations, and you will see that what I said is exactly right. So astronomers, easily intimidated by theoretical astrophysicists, I guess, said, "Oh, sorry, we'll do better. We'll make better observations." They went back and started doing more observations starting in 1820. From 1820 to 1840, the observations were really meticulously done, but they were still off. And they were still off for a reason that Bouvard recognized somewhere down here in the bottom of this paragraph. He mentions, well, there's a chance that the reason that these observations aren't perfect is because maybe there's another planet out there, sometimes tugging Uranus a little bit in front in its orbit, sometimes pulling it back in its orbit. By 1840, it was clear that that's what was going on. Pretty much in 1840, everybody who was paying attention knew that there was another planet out there, but nobody really knew how to find it. It took until another French astronomer from the same place there in Paris took these observations from Bouvard and turned them into a prediction. This was Urbain Le Verrier. Took these observations showing where Uranus was a little behind and a little in front, and he did the calculation to predict exactly where this new planet should be. He sent his predictions to Berlin, to the observatory there in Berlin. They opened up the telescope, and it was right there the very first night they looked. This to me is still one of the most astounding stories in the history of science, and it's this moment, the history of physics. It's this moment where people first, I think, realize that it's not just, you can make these predictions, you can make these calculations based on physics, but they're really there. You can actually predict the existence of a planet that you didn't know anything about just by using this relatively new physics that people were developing at the time. Not surprisingly, Bouvard became really, really famous for making this observation. He was called the astronomer who discovered a planet with the tip of his pencil. He's got a statue in Paris looking straight up the boulevard north towards Notre Dame. I think he's one of something like 70 people who got his name inscribed in the Eiffel Tower. Very famous very quickly. And other astronomers very quickly realized, this is a great way to get famous. I'm going to do this too. And so people started predicting new planets beyond Neptune. The first time that this happened was about 3 months after Leverrier predicted the existence of Neptune successfully. Somebody said, oh, actually, Uranus and Neptune are not quite where they're supposed to be. There must be another one out there. And people started rushing around looking for it, making new predictions. The most famous of these new predictions came from American astronomer Percival Lowell. Percival Lowell was looking at observations just like the ones we're looking at here of Uranus and of Neptune. And he was convinced that there was a massive, massive planet just beyond Neptune that was tugging Uranus and Neptune in its orbit. He did a bunch of different calculations. He calculated and called them successively. There was planet P, Q, R, S, T, U, V, W, Y, and his final calculation that he thought was right was planet X. A lot of people think planet X just means 10 or mysterious or something, but it was actually it was just the next letter in the alphabet for Percival Lowell. Planet X. Planet X was this massive planet. He thought he knew where it was. He founded the Lowell Observatory in Flagstaff, Arizona, just one state over from me here in California, to look for this planet. Sadly, he passed away before anything could be found, but they hired Clyde Tombaugh, a farm kid from Illinois. He was something like 20 years old, to go search for planet X. Took a picture of the sky, and it looked something like this, and there it is. Do you guys see it? No, nobody sees it. Okay, well, Clyde Tombaugh didn't see it either, because he realized that the only way that you could see a planet and know it was a planet is what Herschel had realized all those years ago, is you take a picture, you take one the next day, and you watch it move. Anybody see it move? No. Okay, here we go again. First day, take a picture the second day. Anybody think it moves? Yeah, I know you think you saw it, but you're wrong. Let's try again. Here's one. Here's two. Maybe you really saw it. The fourth time, everybody gets it the fourth time. I don't know why. Here's one. Oh, that's why. Here's two. There it is. Those observations are the actual discovery of Pluto in 1930 by Clyde Tombaugh. New York Times headline at the discovery: "Ninth planet discovered on the edge of the solar system, lies far beyond Neptune." So far, so good. Sighted January 21st, all true. Seen in Flagstaff, true. The sphere possibly larger than Jupiter and 4 billion miles away. 4 billion miles away is about right. Possibly larger than Jupiter. It turns out that's wrong by a factor of 250,000. And the reason it's wrong by a factor of 250,000, the reason they got it that wrong is because of that last phrase, meets predictions. Percival Lowell had predicted a massive planet out there. And so when Clyde Tombaugh found something beyond Neptune, the assumption was it must be that planet. And that planet was something like the size of Jupiter or even larger. And so this is why Pluto was called a planet to begin with, because people were wrong about how big it was by a factor of 250,000. If it were the size of Jupiter, however, it would be huge, even in this picture. It's, I think it's that one. Is it that one? Yes, it was that one. And there it is down here in that one. It would be huge. It would be maybe this big, but it's not. It's this tiny, tiny little thing. It looks tiny. And astronomers at the time were confused. Why does it look so tiny if it's so big? These days, we actually know why it looks so small. Anybody know why it looks so small? Anybody? That's right. Because it's small. And in this whole debate about Pluto and whether it should have been a planet or not, I mean, everybody knows that Pluto's small, but I think we lost sight of just how truly tiny it is compared to whatever else is out there. So I'd like to show this picture of the planets in our solar system: Jupiter, Saturn, Uranus, Neptune. Jupiter is so big that you can't even fit it on one screen. Here's the inner planets: Mercury, Venus, Earth, Mars. Even put the asteroids on there. These are actually all the asteroids that are big enough to be one PowerPoint pixel. There's 10 of them. And Ceres is big enough to be 3 pixels across. Now I'm going to add Pluto in there. Don't blink. You'll miss it. There it is. Tiny, tiny, tiny little Pluto at the edge of the solar system. It is much, much smaller than what you would think for a planet going on out there. More importantly than its size, though, is the realization that Pluto had a strange orbit. Even back when it was discovered in 1930, it was pretty clear it's a strange orbit. Here are Jupiter, Saturn, Uranus, and Neptune. We put Pluto on there. It goes inside the orbit of Neptune, which is pretty strange for a planet to do. And what's even stranger is if you put the whole solar system on its side, you'll see that Pluto is not actually in the disk of the planets. It's tilted by about 19 degrees to the planets. So it was always a weird oddball that even when it was called a planet, it was an oddball planet. These days, however, it's not an oddball at all. It's also not a planet. It's not an oddball at all because astronomers have found something like 2,000 other objects like Pluto beyond the orbit of Neptune. Some of them beyond the orbit of Neptune, some of them inside the orbit of Neptune. All of them have these orbits like Pluto, which are tilted one way or another compared to the plane of the solar system. They're elongated. Some of them go inside of Neptune. Some of them go much further outside. It's really clear once you see what's really out there that Pluto was just the easiest to see of these objects in what we now call the Kuiper belt. And Pluto really is just one of these objects. Doesn't really shouldn't be classified with the planets. It's too small to be classified with the planets. Doesn't have the orbit of the planets. The other interesting thing about the discovery of Pluto and these other objects in the Kuiper belt is the realization that all of those hints that there was a giant planet beyond the orbit of Neptune were wrong. It was all based on thinking that Uranus and Neptune were being perturbed in ways that we now know they're not. It actually is true. Bouvard was eventually right. Astronomers needed to make better observations. And when the better observations were made, Uranus and Neptune are exactly where they're supposed to be in the solar system. Everything moves exactly where it is. There are no other objects out there doing anything. Everything makes sense. At least that was true until 2003. In 2003, we discovered this very strange object in the outer solar system with an orbit that was not even part of the Kuiper belt, well beyond the Kuiper belt, this object called Sedna. Sedna is on this incredibly elongated orbit. It takes 10,000 years to go around the sun. More importantly, it also never actually comes close to any planet. You can't put an object on an orbit like this without disturbing it somehow. All objects start out on more or less circular orbits. To get on an orbit like this, it has to be tugged or disturbed by some gravitational force. This never comes close to any gravitational force. So at the time, we hypothesized, oh, maybe there had been other stars going past in the solar system at some point. Maybe it tugged Neptune, tugged Sedna out. Maybe we'd find more of them. We started looking for more and more, and we found something totally unexpected. We found more objects like Sedna, but what we found is that they were all tugged off in one direction. This actually doesn't make any sense. These objects, unless they're being pulled along right now, they would eventually distribute themselves relatively evenly through the solar system. The fact that they're all in one direction means something's tugging on them right now. And so this is the point where I walked down the hall back when you could actually just walk down the hall and talk to your friends and your colleagues. I walked down the hall and talked to my colleague Konstantin Batygin, who in fact is a theoretical astrophysicist, to help me try to make sense of this. I was like, Konstantin, what is going on? These are all pulled off in one direction. And we both kind of looked at it and said, the obvious solution is that there's a giant planet, but that's crazy. Nobody wants to be the 36th and 37th person to say there's a giant planet still out there and be wrong once again, because everybody who's ever said there's a planet to be discovered out there has been wrong. So we spent a year trying to figure out what could possibly be pulling these objects in this direction that wasn't a planet. We looked at the whole Milky Way galaxy maybe pulling it, maybe that there was enough individual mass in these objects they could kind of pull themselves together. Maybe there was something else coming on the inside. We couldn't come up with anything. And in fact, when we looked closer and closer at the idea of a giant planet, we realized a giant planet works really well. our first idea was that you had a giant planet with an orbit sort of like this, goes on the outside of all of these objects, and it kind of hugs them and keeps them in place. And that's what's going on. Oh, I should have showed you one thing that I forgot to show you, which is that when you turn this set of objects on their side, they too, like Pluto, tilted compared to the solar system. These are tilted compared to the solar system, and they're all tilted in about the same direction too. So they're being pulled off in one direction and being pulled up in the same time. Very strange behavior that should not be going on unless something is actively doing it. So what is that something? Well, we decided to look in the idea that maybe it was a giant planet, reluctantly, against our better judgment. And we did it with both some theoretical calculations, but the best way to do it was really to do a computer simulation. So I'm going to show you some of our earliest computer simulations. This pink thing is the orbit of a planet, and these blue ones are orbits of these very distant objects. This is supposed to represent the very beginning of the solar system, when things are everywhere. There's a ton of objects going in all directions. What we're looking for is for objects to get trapped in this region enclosed by this planet. So this is a very quick look at 4.5 billion years of time. My simulation is not running here. Let me try it again. There we go. Okay. Let's see if I can start it again. Come on. Well, we'll just let it go. There it is. Okay. 4 billion years of time. We're looking for things to get trapped right here in this region here. One thing to notice is very quickly, most of the objects disappeared. Most of these things in this region of the Kuiper belt, these elongated things, it's because they crossed orbits with this planet, and crossing orbits with a giant planet's bad news. You go away really quickly. The other thing to notice is that these things on the inside, they are not going away. In fact, they're just going, the orbits are slowly going around in circles. This is called precession. This is actually why we expected all the objects to be in all crazy directions, because they just uniformly go in all directions. The planet, though, is slowly capturing objects over here, like that one. Oh, no, not that one. How about this one? This one, no. How about, here's one. Here's one that's about, nope, this one. This one stays, no, no, no. When you see them disappear, it's because they've been ejected. This one, nope. This one. Well, so there's bad news. Our theory was utterly wrong. Nothing gets caught over here by the planet. Everything that shows up over here briefly is quickly ejected. But after 4.5 billion years, look what happens. All of these objects are still there. We had it entirely backwards. It's not that the objects over here get captured. It's that the objects over here stick around longer. It's not really that they're captured by the planet, but they're harder for the planet to eject. And the reason, at first we thought this makes no sense at all. They're crossing the orbit of the planet. They have to be ejected. And then, of course, as soon as we thought for more than 2 seconds, we realized, this totally makes sense. We should have thought of this to begin with. Orbits like this, they're sort of like cometary orbits. They spend most of their time out here, and then they come fast in through here. Most of their time out here, fast in through here, which means mostly they're out here. The planet, likewise, is mostly out here. When their orbits cross, they cross on, they're very fast when they cross. So they don't spend much time close to each other. Imagine, however, an object that's on an orbit like this. It spends most of its time out here. It's close to the planet. Most of the time, it gets ejected pretty quickly. So these are the ones that stick around for the longest time. So seeing orbits like this mean that a planet has to be over here like this. And the fact that these are tilted like this shows that the planet, likewise, has to be tilted like this. This was pretty exciting. So Konstantin and I had done these computer simulations, done these calculations, realized that a planet does a really good job of explaining what we see. But it wasn't enough. It wasn't enough because it's relatively easy to explain things in astronomy. If you give me some phenomenon out there, I could probably spin 2 or 3 different stories that explain what's going on. Explaining is easy. Predicting is hard. What we really wanted to do was make a prediction and see if that came true. And until that happened, we weren't willing to say that we thought that there was a planet out there. So one obvious prediction: when we find more and more objects, they will be aligned the same way that these are. that's a slow prediction because it was going to take years to find more and more of these objects. The prediction was that they'd be aligned, but not all of them would be aligned. It's not 100% efficient. There should be a couple that are in the opposite direction. So we predicted that, but we would have to wait for years to see if that was going to turn out to be true. The other thing that was interesting in the computer simulations, though, is that there was another set of objects that kept getting captured into place. And it's that as the objects here were being slowly removed from the outer part of the solar system, they did something weird. They had their orbits twisted in a way that the best I can do is draw it on your screen here, which is that if here's the sun, here's the objects with orbits like this, the orbits got twisted downward, so at a 90-degree angle from where they are, but also twisted by 90 degrees in their direction. So instead of going in the same disk of the solar system, they're suddenly going perpendicular. And so they get twisted that way. They also get twisted upward. So it's almost like this cluster of objects that exists over here has wings on either side of it. And that was a weird prediction, given that we had never seen anything like that in our lives. And so it was a scary enough result from our simulations that we were close to throwing away the theory because we could not find anything like that, and we knew we should have found something like that. It took until one day when I realized that there was an entire data set that we had inadvertently not been looking at because there were objects that I didn't think were going to be very interesting. I opened up that object and I realized that there were in that data set catalogs of objects that were on these perpendicular orbits, but I didn't yet know where they were lined up. So I rushed over, I got Konstantin, I got in my office, I said, okay, look, there are objects now. These are either going to be lined up in wings like we thought they were going to be, and we're right, or they're not, and we're wrong. And so we plotted them on the screen, and they were exactly where we thought they were going to be. These are the objects. They're perpendicular from the aligned ones. They're down like this. And also, as you can see, they're perpendicular to the plane of the solar system. This was it. This is like, there is no reason that these objects should even exist at all. Nobody had any explanation for these, and our theory predicted that they should come in. I think both of our jaws dropped at the same time, because we went from, oh, this is kind of fun, there's a cute idea that there might be a planet out there, to there's a giant planet out there at the edge of the solar system. And I think we just stared at each other like, I can't believe this. So we published our paper, made its predictions, and it's a little bit strange to say, people have been predicting a new planet beyond Neptune. Like 35 other astronomers have made this prediction over the past 150 years, and they've all been wrong, but we're right. But the fact is, they've all been wrong, and I think we're right. I think there really is a giant planet out at the edge of the solar system, and I think we're on our way to find it. So let me tell you a few more things about it. Now that this was our original inclination that there's something there. There are now, as I said, the prediction said there should be more objects. Originally, there were just 6. We've now doubled it. There are 12 objects. These are the ones fanned out in this direction. And reassuringly, there's even one in the wrong direction, like this. This is Neptune, and here's the planet, the orbit of the planet in yellow. There's one in the wrong direction, like there should be, and all the rest of these in the right direction. So the predictions keep getting better. The idea that there is a planet out there that keeps getting stronger. That we've actually at this point made more and more predictions, which I'm not going to get into because I just want to tell you what we know about the planet for now. So what we knew initially, we called it Planet 9. We knew that it was something like 10 times the mass of the Earth. 10 times the mass of the Earth is interesting because it sits kind of midway between Uranus and Neptune, which are around 15 times the mass of the Earth, and the Earth, which is precisely 1 times the mass of the Earth. It's in between. There was nothing like this known in our solar system, so we don't really know. Is it more like the Earth? Is it a solid body like the Earth that you could go drive around on, or is it a gas giant like Uranus and Neptune? We don't know the answer to that, but one thing we do know, as we've continued to study, we now realize that our original paper said somewhere between 5 and 10 Earth masses. We've narrowed that down to maybe something like 6, maybe plus or minus 1 Earth masses. So it's still in that weird no man's land between 1 and 15. But it's interesting because even though we don't have a planet like this that we have seen yet in our solar system, throughout the galaxy, this is one of the most common mass planets that there is. And when they're found around other stars, they're typically gas giants, not super Earth. So our best guess, is that this is a gas giant, not a big frozen solid body. If it's a gas giant, then it makes it not some ever so slightly larger than Pluto. Let's argue about whether it's a planet or not. It's the 5th largest planet in our solar system. This thing is huge. This is what you would expect a 9th planet to look like, not one of these many objects out there in the Kuiper belt. So this is when when we call it Planet 9, it is just to drive home the point that this is what we expect for a real planet in the solar system to look like. Okay, so we know about how big it is. Where is it? How are we going to find it? Well, I'm excited to show this. This is actually a figure from a scientific paper that we just published a month ago. The idea that Planet 9 is out there has been around now for about 5 years, and it took us until this year to finally be able to interpret where all those objects are that we're seeing and invert that into a prediction of where Planet 9 is. This is almost like Leverrier, who took those observations of Uranus and turned them into a prediction of Neptune. But Leverrier was better. We'll never get our names inscribed in the Eiffel Tower. And Leverrier had a better job because he didn't just say it's out here somewhere. He said it's right there. Go look right there, and it's right there. We, on the other hand, we can't pinpoint where in its orbit it is. We can only pinpoint what the orbit is. So basically, we get a swath of the sky where it should be. So I'm gonna show you these maps, but let me walk you through them first. This is a map of the whole sky. As if you take a globe and squash it flat, you can do a whole globe in a sort of picture like this. In the sky, this line is the equator of the sky. This line is the plane of the ecliptic, where all the planets are. If it's clear out tonight, probably never clear in Glasgow this time of year, but if it is clear out tonight, go out and look at it. You can see the ecliptic. You can see Venus. You can see Jupiter. You can see Saturn. You can even see the moon out there, all lined up, and that's drawing you the plane of the planets. It's a beautiful sight if you have nice clear skies. That's the plane of the planets. These two big lines are the Milky Way galaxy. So the Milky Way galaxy goes across here, and this is where Planet 9 is. The red is where it's most likely to be. Blue, it's definitely not there, and the other colors least likely to be. Its most likely locations straight through here. Straight up through here is well, it's one of my favorite spots in the sky that I'll show you here in a minute. But it's basically the Milky Way galaxy in the wintertime. It's the location where this is actually the ecliptic. This is Gemini, the constellation Gemini. I'm in fact a Gemini. It's in Gemini. Maybe astrology is real. Who knows? No, it's not real. We all know. But it might be in that direction. So the other interesting thing that it shows you is how far away it should be and how bright it is. So, some of you probably amateur astronomers understand magnitudes. Stars in the sky are between about 0 and 5 magnitudes. So they're really faint down here. Small numbers are, they're really bright. Small numbers are brighter. Astronomers are weird. It's not our fault. Blame the Greeks. These are some really faint objects, but they're not that faint. If Planet 9 were like 18th or 19th magnitude, that's backyard telescopes. They're big backyard telescopes, but still backyard telescopes. If it's 20 or 21, it's modest telescopes. There are 100 telescopes around the world big enough to see it if it's that big. If it's out here at 22, 23, there are only like tens of telescopes. And if it's way out here, it's like a few of the largest telescopes. So it's somewhere between easy and hard, which is interesting because it could have been way up here and impossible, or way down here, or we would have discovered it. But it's somewhere in through there. And it's how far away it is, in through here is like 400 astronomical units. Astronomical unit is the distance from the Earth to the sun. 400 of those is something like 1.5 times more distant than Neptune. So it's way out there, but it's only moderately faint. And it's only moderately faint because it's so big. It's probably should be easy to find. So how are we going to find it? So we are in the systematic search. The way you find something like this, you have to search this whole region of the sky, but you have to search it with the appropriate telescopes that can see the appropriate distance and the appropriate faintness. So the easiest things to do are to do the bright ones first. So we have, oh yeah, here it's really, really hard. The brightest ones, well, we're doing this with the 4-foot Schmidt photographic telescope, usually known as the 40-inch telescope at Palomar. This is a telescope that was built to go along the huge Palomar 200-inch telescope back in the 1940s. And it's the side telescope. It's the one that was made to map the sky to have the Palomar telescope know what to do. There is no longer this dude sitting smoking a pipe running it. It's now running robotically with a huge digital CCD camera in this whole backplane, looking at the sky night after night after night, every 3 nights, taking images of the entire sky. This is the same telescope, incidentally, where 20 years ago we used it to discover Eris and Sedna and Haumea and Makemake and the dwarf planets that led us to correctly classify Pluto for the first time. And now it's being run to do that kind of survey night after night after night. So we've used that, looking night after night after night. It's not a huge telescope, but it can see to about 20th magnitude. So it has done, this is that same map that I showed you before. It's a little messier looking because I have fewer test objects inside of it, but assume it's the same thing. With the 200, with the 48-inch telescope, we did a full search, didn't find it, bad news, but it covered this much of the sky. So if you notice, all of these bright things have been ruled out. We didn't rule out the bright ones over here, because that's it's southern part of the sky. We can't see that part. The Earth is in a way. But anything up in here, the bright ones, the close ones, ruled out. Pretty good. You can see it went to about 20 and a half magnitude. We actually ruled out something like 56% of parameter space by doing that. So we had a pretty good chance of finding that. I was sad when we didn't find it. I ran it over the weekend a couple months ago while I was here, and I told my daughter, 16-year-old daughter, I was like, okay, I'm going to run this. It's going to take about a weekend to run. I'm going to look Monday morning, and we're going to found it. So let's go look. So we both got up, ran to the computer. Wasn't there. Very disappointing, but we're carrying on. So the next survey that has already accomplished it is called the Dark Energy Survey. This is that same region of the sky where we expect it to be. This is the biggest area of the sky. The sky's just been rotated by 90 degrees, which is why it looks slightly different. But their survey covered this thing that looks a little bit like a tank. It's really too bad they covered a lot of the sky down here where there was no Planet 9. If they could have just shifted over here, would have been so much better. But they did cover this region here with a big telescope and completely ruled out any Planet 9 there. So we go from here to there. You can see this little bite that they took right there. Didn't find it. You would have heard if they'd find it. So we move on. Next telescope is, you can't see it. This is Mauna Kea. These are a couple of my favorite telescopes on the mountain of Mauna Kea. These are the Keck telescopes that I sort of grew up using. The Subaru telescope that we'll talk about in a minute. But over here on the other island, the island of Maui on the mountain of Haleakala, is a telescope called Pan-STARRS. Pan-STARRS is actually very similar to the 48-inch Schmidt telescope, and it also looks at the sky night after night after night, but it spends more time, so it sees fainter objects. Also spends more time, so it doesn't do the sky quite as frequently. So it hasn't done as much coverage, but it's done it for 5 years. So we are in the process, I will tell you, we're in the process of going from this. When Pan-STARRS is done, it will have ruled out that much of the sky. And that much of the sky is about 80% of the sky. I say ruled out, it might find it. I actually don't know. This analysis it takes about 2 months to run instead of 2 days to run. So it is literally running on my computer right now. Every morning I check to see if maybe it found it. Didn't find it this morning. We're getting there. The worst news, if you don't find it in Pan-STARRS, there's about 20% left. And it's the faintest stuff. It's faint stuff all here, far away, and it's in this swath of sky right here. This will be the last remaining spot. There's a little bit down here for bright objects that we can pretty easily clean up. So if anybody's got a telescope down there, go look down there. We haven't done it yet. But for the faint objects here, the last little cleanup area is with this telescope. This is the Subaru telescope. The Subaru telescope is an 8-meter telescope, can see faint objects, and it has the one of the largest astronomical cameras on a large telescope anywhere. And actually, here's Konstantin and I at that telescope. The camera is way up here at the top of this huge telescope. This is a really distorted picture, so you can't even tell how big that telescope is. This is like a 5-story building, and us standing at the bottom of it. We are searching with this telescope ongoing. We're actually going to be there not this weekend, but next weekend, searching one of our favorite areas of the sky, hoping to find it. Favorite area of the sky, where it might be. When we do that, well, it's this little region and through here, and it's this region and through here. I told you it was Gemini, but it's really Gemini, Orion, Taurus. It's one of the most noticeable regions of the sky. I love the fact that if people ask me where I think Planet 9 is right now, actually I think that's it. I think we can all see it. If it's clear, I know there's no chance it's clear in Glasgow tonight, but if it magically clears up right now, as you leave wherever you are, I was going to say tonight, it is tonight for you guys. Walk outside and see the ecliptic, Venus, Jupiter, Saturn, all lined up like that. But just past the ecliptic, you'll see this scene that you're looking at right now. You'll see Orion. You'll be able to see Taurus. You'll be able to see Gemini up there along the ecliptic. And do like I do when I do this. I'm going to go out tonight. It's California. It's beautiful out here tonight. We'll have perfectly clear skies. I'll see these things. And every time I see Orion, I kind of get this feeling like this is not some abstract project that we're working on. To me, this is real. It's out there. I can feel it tugging us, telling us that it's there. So I think we're on track. We're going to find it in a couple months if we're lucky, in a couple years if we're less lucky. But it's out there, and it's not too faint for us to see. And so I think I want you to end with the idea that to stay tuned, that there is a giant planet, will be found in our lifetimes, and it will be found and studied in detail with every telescope we can get our hands on. And I'm as excited as can be about these possibilities. I just want to end with that same slide that I showed at the beginning. This slide, some people might recognize as our take on the advertising poster from the famous movie from 1958, Plan 9 from Outer Space. It's a famous movie, famous only for once being listed as the worst movie ever made, but it's got to be pretty good to be that bad and listed as the worst movie. But it's pretty bad. If you've never tried to watch it, A, don't. It's terrible. B, if you do, you can actually find it on YouTube and watch the whole thing. But it's even funnier just to read the plot, because it makes no sense. It's got vampires, it's got zombies, it's got space aliens, it's got Vampira, it's got graveyard scene. It was directed by Ed Wood, this very famous American director who's famous for both great movies and for really terrible movies like this. But he was, in addition to being a great director, I like to think that Ed Wood was prescient. The year is 1958 when he's making this movie, and he makes this poster and includes the graveyard scene. And in the graveyard scene of Plan 9 from Outer Space, 1958, Pluto is well and good a planet and good standing. And here in the graveyard, let's zoom in on the graveyard scene. There it is, R.I.P. Pluto, right there. Ed Wood knew. It took the rest of us another 40 years to figure it out, but he knew all along. So as I said, stay tuned. I think there will be a planet out there for you guys to find, and I hope you have clear skies tonight. Go out and feel its tug out in the direction of Gemini, of Orion. And if you feel the direction, let me know so I can point my telescope in that way. So thanks for coming, and I'm happy to answer questions.
Thank you so much for that, Mike. That was phenomenal. And it was so nice to see those visualizations of kind of of where you think Planet 9 is. We have those in the planetarium, and it was a nice reminder of kind of how exciting it was. And
is it clear? Is it clear outside?
I have been in the basement for the last 2 hours, so I'm not sure, but it has been clear the last couple of nights it does
Whoa. Okay.
happen.
All
So
right.
yeah, go
I just
outside,
assume
folks,
I
and
assume
look.
it rains all the time, all winter long. But
Sometimes it snows.
oh, so it was okay.
So we do have some time for some questions. I think we're gonna address the dwarf planet in the room to kind of start with. So were you surprised, because it was quite an emotional response by the public to the kind of reclassification, demotion, whatever you want to say, of Pluto? I'm firmly on Team Dwarf Planet, just to kind of put that out there. But were you surprised by that?
I wasn't surprised at all. I 100% knew that people would have a hard emotional time, and I understand why. It's Pluto is what we grew up with. It's part of our neighborhood in the sense that it's really if you get people to describe where they live, they can talk about
Mhm.
their town, they can talk about their country, they can talk about the earth and where things are. The next biggest thing they can talk about is the solar system, and that's, for most people, that's about as far as they can picture themselves in, and the most distant thing they can think of is Pluto. So it's part of the mental neighborhood. And just like if I were to suddenly say, nope, this is not part of your country anymore. Although, I mean, you might be happy if I said that for some of you. It's a hard emotional response, and I totally get it. And it helps that Pluto was named after a cartoon dog and cute, and okay, it wasn't named after the cartoon dog, but still associated with a cartoon dog. So I loved Pluto too. I just think that it was. So I understand the reaction. I don't even think it was reclassified. I think it was correctly classified for the first time, is the way I like to think of it.
I mean, no one was protesting when Eris was not Eris, Ceres was
Ceres,
reclassified, because that was considered a planet briefly as well.
it was considered a planet for longer than Pluto was. Well, no, that's not true. But it was considered a planet from its discovery in 1801 until about 1850, when there started to be more and more asteroids. But it's exactly the same thing. Ceres was just one of the brightest asteroid, and when we finally realized that there are many, many, many other asteroids in that asteroid belt, we're going to call these things asteroids, minor planets. They were sometimes called. No one quite settled on the right name. Same thing with Pluto.
Yep. Thank you. That's a brilliant answer. I think we've got some questions from YouTube and from Facebook. So we're going straight in from Jamie asks, will the new James Webb Telescope, when it eventually launches, touch wood, dramatically improve the chances of finding Planet 9 during a sky search?
So two answers to that question. Answer one is it will not help anything if they drop it or drop things on it, which they just did yesterday. So we'll hope that that's fixed. So the answer is no, actually. So James Webb is not designed for big surveys of big areas of the sky. It'll be fantastic once we find Planet 9 for studying it, in particular its atmosphere and its overall characteristics. But no, it looks at tiny areas of the sky at once. So we'll find it with telescopes here on the ground. But then we have a couple of things we want to do. Like the day we find it, we want to use James Webb, assuming it's up by then. We want to use Hubble Space Telescope to see if it has moons, if it has rings. And then we want to use some of the other big radio telescopes to measure the thermal emission coming from it. So we have a lot of exciting projects. Finding it is fun. Discovery is great, but it's actually the things we'll learn once we find it that I'm equally excited about.
Yeah, it'd be nice to know what it's made of, what it could potentially look like. Thank you. So I think we've got quite a few, actually. The chat's been pretty busy tonight. So Yuri Young says, in another video that you said that Planet 9 could explain why the plane of the solar system is tilted 6 degrees compared to the tilt of the sun. Is there any plausible theory on why beside Planet 9?
So it's interesting. When we first started talking about Planet 9, and when we knew less about how big it was and how far away it was, we were pretty excited about that possibility. So all it is that a planet that's inclined, it's on an orbit that's inclined, and it's massive. It just sort of turns the solar system like a top, precesses it, but the sun doesn't. So the sun stays still while the solar system precesses, which means that according to us, because we're here, it's the sun that's moving. So the sun is tilted. So the sun is tilted by 6 degrees. It turns out that the mass of Planet 9, now that we know the mass of it and about where it is it's just not quite massive enough to have done it. So it was a cute theory, but it doesn't quite make sense. So the real question is, are there other things? Probably the answer is that when we still had a disk of material that the planets were forming from, a star came by and tilted the whole disk and not the sun. Again, it's tilting, not tilting the sun. We see this around other stars a lot too. So we're not unusual in having a tilt. Some planetary systems are tilted by many, many degrees. So it's something that it would have been fun had it worked out, because it's just it's a great idea, but doesn't quite work.
Okay. It's nice to know that we're not unusual. So Kate's got a good question there. So from Facebook, hi, how long for Planet 9 to complete one orbit? So I guess how long's a year?
So based on how far we think it is, there's still a range of possibility for how far away it is, but it's probably about 10,000 years to go around the sun. So, think about where you were 10,000 years ago. That's the last time it was, or actually, we think it's its furthest point. So if you think about where you were 5,000 years ago, that's when it was at its closest. It'll be easier to study in 5,000 years. So I invite everybody to come back. I'll tell you what we found then.
Astronomy is all about patience, eh?
Yeah, exactly.
Thank you. So Stephen from YouTube has asked, it said it's an awesome talk. Thank you. Totally agree on that count. Could it be possible that the atmospheric composition of Planet 9 could impede detection?
Yeah, so that's a really interesting question, because we, of course, do not know the composition of the atmosphere. We don't even know for sure that it's a gas giant planet. So it could be just because I said that around the galaxy everything at that mass seems to be gas giant. We could easily be fooled. So there are many different assumptions that we made that could make it harder to detect. So if, for example, it were a solid body, it could have a really dark surface. It would be smaller to begin with, because a solid body of the same mass, we know the mass, we don't know the size. A smaller body of the same mass would be smaller and also darker, and the whole thing would shift that brightness up by a ton. So where it was suddenly easy to discover because small telescopes can do it, suddenly it requires really big telescopes. That's my nightmare scenario. I don't think if it's a gas giant that there's anything you could put in the atmosphere that would make it harder to see, but I do think you could make it a giant icy body that would make it really hard to detect and ruin my year, I think.
So sort of less to do with the atmosphere and more just to do with the composition of the planet itself.
Yeah.
Okay. Hopefully it doesn't ruin your year. So Zach has asked from YouTube, do you have a hypothesis about how a planet of this size came to be in this area? Do we know if it's typical for similar objects around other stars, or is there no such thing as typical?
So we do. So again, I will emphasize that we don't know the answer to that question. How did it get there? But all we know for sure is there is something with approximately 6 times the mass of the Earth on approximately this orbit. But it's fun to speculate how it got there, or even do better than speculation. So our best guess on how it got there, and it, again, just a guess, but our best guess on how it got there is that it used to be, that it formed around Uranus and Neptune, same region as Uranus and Neptune, and rattled around there for a while, got a little bit too close to Saturn at one point, and got flung out to the outer part of the solar system, and has been lurking there ever since then. So one of the reasons why we think that Planet 9 is such a good hypothesis for all these different things and how it got there is because of the other part of the question. We definitely see planets at similar distances around other stars. We haven't ever seen anything quite as small as Planet 9, only 6 Earth masses. The things we see around other stars are more like the mass of Jupiter and larger, but that's just because we can't see things that small yet. So we've only been able to see the really big ones, but it's not weird to have planets out there like that. So the idea that we would have something like that in many ways is kind of mundane. It just seems like, yep, planetary systems should do things like that. No big deal. So the only reason it's provocative and exciting is just because we didn't know it was there before.
It's quite nice to know that we're sort of finding out things about other solar systems that are helping us learn about our own solar system.
Absolutely.
I guess so. I like that. We'll go on to the next one. I like this one from Ross. What would you call Planet 9?
So I have to tell you, astronomers, or at least me, are very superstitious people. And everybody has their superstitions that they use to clear the weather, to do whatever. One of my very
Lucky
strongly
peanuts.
yeah, exactly.
Yep.
One of my strongly held beliefs is that if you name something before you find it, you'll never find it. So we have legitimately never even thought about what to name it. And if anybody wants to give me suggestions, I'm going to stick my fingers in my ears and go, nah, I'll just take my headphones off. When we find it, we will come up with a great name. So I love the naming aspect. All these dwarf planets that we know and love, I basically named because nobody else who was on my team thought it was interesting, and I thought it was super cool. So we will come up with a name, and it'll be great, and we'll love it. But we're not going to think about it.
You're not going to think about it. Yep, that's
at all.
Entirely fair. I like that. So that's the sort of planetary science version of NASA's Lucky Peanuts for
exactly.
Right, gotcha. Okay. Sorry, Ross. We'll have to move on to the next one. So if we find planet 9, does this extend the edge of our solar system, or does the existence of 9 redefine the extent of our solar system?
So neither, I think, is the answer. Our solar system actually extends much further out than planet 9 even goes, by a factor of about 100. So you've probably heard of the Oort cloud, where comets live. Or the Oort cloud is maybe 50 times further away than planet 9. So the the sun's gravity dominates the space all the way out to about halfway to the next star. So there can be things really, really far still out there. Now, you might have heard all these discussions about when the Voyager spacecraft is going, is it left the solar system, not left the solar system, blah, blah, blah. So it's not there. It has not left the gravitational influence of the sun. And that's how we define the solar system. What it's left is the heliopause, the magnetic field influence of the sun. And that's just because the galaxy itself has a magnetic field that's overwhelming the sun's as you get far enough. But the gravitational field is still out there.
So it's not going to completely change our definition of the size of the
No,
solar
but it
system.
really it does change your concept in the same way that, I said Pluto was the biggest thing you knew about in your neighborhood. Changes the neighborhood. This is something that people will learn about, and it will change everybody's concept of how big the solar system really is.
And we're going to need some new models for the planetarium.
We will.
I think we've got time for a couple more questions. So we've got, what are the chances of planet 9 being smaller, so 2 to 4 Earth masses? Would it still be able to shepherd the trans-Neptunian objects? That's what TNO stands for. And would it make it harder to find?
Yeah, we don't think there's any chance for it to be that small. So the way that we figured out the mass and the locations is a huge series of computer simulations like the ones that you saw. And so we have simulated lower mass objects, and they just don't do it. You need enough mass because you're pretty far out there. You need enough mass that even at that distance, you can cause these effects. You can take a smaller one, like 2 to 4 Earth masses, and bring it closer, but then it does the same thing, but it does it closer. Then it would do things to the Kuiper belt objects that are closer, not the ones that are distant like that. So we've tried all the different sets of parameters. Can't get one like that to work. Okay,
so you're pretty confident with the 6 Earth masses plus or minus 1-ish.
Yeah.
Okay. I think we've got another one. So talking about the Oort cloud, which we mentioned a couple of questions ago, is planet 9 far enough out to perturb anything in the Oort cloud?
Absolutely, and it does. And one of our big unknowns, where our predictions of where planet 9 should be and how close it should be, all predictions come with caveats and assumptions and everything else. And one of our assumptions is that the objects we see that have been sort of captured by planet 9 started out from the inside, like those simulations I showed you. And if that's true, I think our predictions are pretty solid. We now realize that planet 9 is indeed pulling things from the Oort cloud too. And when it does it's a little bit more chaotic, and they spread out a little bit more. And it could be influencing our models. We're not taking that effect into account. And it could be fooling us into us thinking that planet 9 is a little bit closer than it really is because of all the spread and all the objects. So we're working on that now. So we know the answer is yes, it definitely pulls things in. And now our next question is, how frequently does it? are more objects pulled in than pulled out? And does that affect things or not? We don't know the answer yet. But I do lose sleep about that sometimes.
Hopefully not too much. We've got time for just one more question. So what's next when you find Planet 9, other than naming it Planet 10?
Planet 10, it is entirely plausible that there's a Planet 10 or 11 or 12. As I said earlier, the solar system extends out 50 times further. Eventually you get to places where your orbits are not particularly stable, and so maybe it's harder to exist out there. But there's room beyond Planet 9. Now the problem is, and this is what I say, particularly if there are any kids out there they're listening, I showed you that picture of how faint Planet 9 is, and it's kind of perfect. We have the telescopes today to find Planet 9. We also have the telescopes today to find those distant objects that are being influenced by Planet 9. So Planet 9's ours. Back off, kids. That's what I say. Back off. But Planet 10, I can't find Planet 10. Planet 10 is too far away for the telescopes we have. The objects that are being influenced by Planet 10 are too far away for us to know about right now. So it's going to take a next generation of astronomers, next generation of telescopes, next generation of theory on how to find it. And it's the kids today who have their planet to go be out on the hunt for. So I wish you luck. It's a fun hunt, and it's out there. I don't know if there's a Planet 10, but it might be there. So somebody go find out.
Who knows? I think that's a wonderful note to end on. So hopefully in 20 years, somebody who's watching this lecture right now, who's a bit younger, might get their name engraved on the Eiffel Tower.
Yeah, let me know.
We'll keep you posted. So we are totally out of time. So it's just up for me to say a huge thank you to everyone who's watched tonight's lecture, and particularly to you, Mike, for actually joining us and for taking all of those questions. David Elder lectures will continue. So if you'd like more information on upcoming lectures, please do head to Glasgow Science Centre website. Sign up to the mailing list. We will keep you posted. We'd also love to know what you thought of these lectures, so we can send lots of nice things on to Mike. So we're going to drop a link to a wee survey in the chat, so if you can take a moment to answer that would be tremendous. But yeah, just to say a massive thank you to Mike for joining us tonight. And that's us for the evening, so thank you so much.
Thank you, and go look at the sky.
Yes, if it's clear, fingers crossed. Or you can come to the planetarium. Skies are always clear. On that plug, good night.
Good night, everybody.